All right, let's dive right in. Today we're talking about something that's, quietly changing just about everything. Responsible AI. It's all about one simple idea. How do we build artificial intelligence that we can actually trust? Because, as we're about to see, the stakes are getting higher every single day.
Look, AI isn't just for recommending what movie to watch anymore. We're talking about systems that are making huge calls about our lives, who gets hired, who gets the loan, even what a medical scan might show. And that brings us to the big central question. Can we really, truly trust it?
You see, AI is a classic double-edged sword. On one side, the promise is just immense. Think about an AI that can spot a disease years before a human doctor ever could. But on the other side, the peril is just as real. An AI can learn our worst habits and start systematically denying loans to qualified people or screening out entire groups from job opportunities, all without anyone really knowing why. And it's exactly this tension, right, between the promise and the peril that shows us why we absolutely need a framework for responsible AI. It's not enough to build powerful AI. We have to build AI that's fair, transparent, and ultimately accountable to us.
So let's start with maybe the biggest and most talked about problem, bias. Where does all this unfairness in AI actually come from? The thing is, it's not like developers are programming evil robots. The problem is much more subtle. It's all about what the AI is learning from.
So when we say AI bias, what we really mean is that the system is making consistent, systematic mistakes that hurt a specific group of people. This isn't just bad luck. It's a preference that gets baked right into the model. And it can sneak in from the data we use, the algorithms themselves, or even how we decide if the model is working or not.
One of the biggest culprits here is something called historical bias. See, AI models learn from the world as it was, with all its flaws, not the world as we'd like it to be. So for example, if you train a hiring model on company data from the last 50 years, where men held most of the top jobs, well, the AI learns a pretty simple but wrong lesson. Men make better leaders. It's not thinking, it's just reflecting our own biased history back at us.
And then you've got representation bias. This is what happens when some groups are just missing from the data. The textbook case for this was early facial recognition software. It was trained mostly on pictures of white men, and so its accuracy on women and people with darker skin tones was, frankly, terrible. The model just didn't have enough examples to learn from. Now here's the really scary part. These different biases don't just sit there side by side. They compound, they feed on each other. A model trained on biased data spits out biased results. And if those results then get fed back into the system as new data, well, you've just created a vicious feedback loop that can amplify the original unfairness over and over again.
Okay, so bias is a huge, huge problem. But there's another challenge that's just as tough. Even if a model seems to be fair, a lot of the time we have absolutely no idea how it's making its decisions. We call this the black box problem.
To get our heads around this, we need to know two key ideas. First, you have interpretability. That's when a model is simple, maybe like a basic decision tree, where a person can literally just look at it and understand the logic. But with today's super complex models, that's almost impossible. So instead, we aim for explanation ability. This means we might not get how the whole system works, but we can use special tools to figure out the reason for one specific decision, like why your loan got rejected.
And data scientists have come up with some really clever ways to peek inside that black box. There's a tool called Lime, which basically builds a mini, simple model to explain just one decision. Another one, called SHAP, actually uses game theory to break down exactly how much each factor, like your income or zip code, push the decision one way or the other. And for images, GradCam can create a heat map, literally showing you what parts of a picture the AI was looking at. So we've seen the problems, right? Bias in the machine and this whole black box issue. So what do we do about it? How can we actually start building AI that we can trust from the ground up? Well, this is where the real toolkit for responsible AI comes into play. When it comes to fighting bias, we basically have a three-stage plan of attack. We can jump in before training even starts by cleaning up and balancing the data. Or we can intervene during training by actually changing the algorithm to force it to be more fair. And finally, we can even step in after the model is built by tweaking its final predictions to make sure the outcomes are equitable.
And one of the most powerful tools we have is actually good old-fashioned documentation. People have come up with these brilliant ideas called model cards and data sheets. The best way to think about them is like a nutrition label, but for AI.
A model card tells you everything you need to know about a model's performance and its limits, and a datasheet does the exact same thing for the data itself, which is so important.
Okay, but what about privacy? How do you protect the people whose data you're using? There's an amazing technique for this called differential privacy. It's a really smart mathematical guarantee that lets us learn big picture trends from a dataset, but makes it impossible to learn anything about any one person in it. Basically, it works by adding just a tiny bit of random noise to the data to keep individual identities safe.
Now, these tools are great, but as AI gets woven into the fabric of our society, using them is becoming less of a choice and more of a requirement. So let's look to the future a bit, at how new rules and regulations are changing the game, and at the even bigger challenges that are waiting for us down the road.
A perfect example of this is the big EU AI Act. It's really smart because it doesn't just treat all AI the same. It takes a risk-based approach. Some stuff, like government social scoring, is just banned completely. Then you have high-risk things, like AI used for hiring, which face super strict rules. And then there's low-risk stuff, like chatbots, that just have to follow some basic transparency rules. And for those high-risk systems, the rules are no joke. We're talking mandatory fairness testing, requirements for human oversight, clear explanation, and all that detailed documentation we just talked about. The key takeaway here is that regulations like this are turning responsible AI from a nice-to-have philosophy into a hard legal requirement.
But even with all these rules, there's a deeper, more profound challenge that we're just beginning to grapple with. It's called the AI alignment problem. And this goes way beyond just fixing bias or making things transparent. It asks the most fundamental question of all. As AI gets smarter and more independent, how do we make sure its goals stay aligned with ours?
The classic thought experiment to explain this is the paperclip maximizer. Imagine you build a superintelligent AI and give it one simple goal: make as many paperclips as possible. Well, a powerful but misaligned AI might achieve that goal perfectly by turning every single atom on Earth, including us, into paperclips. It did exactly what you told it to do, but it completely missed all the unspoken human values that we care about, like, our own survival.
And that really brings us to the final and maybe most important question. The tools we talked about today are crucial for building better AI right now. But as these systems get more and more powerful, the challenge itself changes. It stops being about fixing bugs, like bias, and starts being about defining what we as humans truly value, and then figuring out how to teach those values to a machine. So, as AI keeps getting more powerful, how do we make sure its goals stay human?